Okay. Everyone got this paper, right?
Yes.
That's it. Okay. Okay, here. You have to be good at describing motion. Okay, a bus travel at a constant speed is stopped for a short time, then travel at a higher constant. Use the axis to draw a distance time graph for this bus journey. Okay, you have your paper, either you sketch on your notebook or do it. And the second one, they ask what? Use the graph to determine distance from the ground floor to the top floor of the building. Okay, do it now. Okay, how does it look like? Ina?
It's a straight line,
Okay. And then?
and then the straight line becomes horizontal.
Okay, stop for a short while, and then?
And then it becomes increasing straight line.
So, the greater gradient, right?
Yeah.
So, means that gradient here. Right, okay. Get it? It's steeper here. Now, a lift or elevator start from rest at the ground floor of a building. Is a speed time graph for the motion of the lift to the top floor of the building. Now, use the graph to determine the distance from the ground floor to the top floor of the building. Okay. How much?
Distance.
Okay, how much? I mean, what's
Wait.
up? What shape is it? You want to find it? This is
So can we cut it into triangle versus rectangle?
okay, boleh Nina, but you have done your maths, right? What shape is this?
Trapezium. So
Oh,
boleh A plus B times C over 2.
yes. So this is a trapezium. Yes, of course you can cut. But then you already know how to find the area of a trapezium.
Trapezium.
This has to be what? 25 plus what? This is
100.
21 minus 21,
20.
5, 6, 7. 21 minus 7. 1 minus 7 berapa? 16, right? 21, 7. 16. 21, 7 is okay, and then you times with this is the form of trapezium. Great. So what's your answer? What's your answer? Yeah. I mean,
Kejap.
berapa? What's your answer? Half times berapa? 25
I so
times 30 berapa ni? 31,
3.3.3.3.
31. This is 33, right?
3.3.
Wait, 3.3.
Speed dia 3.3.
0.3, right?
Ah.
Okay. So how much? You get 64.35 meter. Okay. Yes? No? Anyone?
Teacher,
Yes.
yang 25 tu plus saya dapat 12.5.
12.5. Is it 12.5? What is
Ah,
12.5?
sebab dekat
You
30 minus 70 over 5.
12.5, so you get berapa?
Wait. 35. 61.875.
5 plus. So you get 6.75, that will give you 61.9, right? So you have 60.
1.9 meter.
Okay, Marisa and Asna, are you okay here? Boleh tak?
Boleh.
Yes.
Okay. No, here. Wait one.
Oh.
Okay, done? Okay, and by deceleration?
The decreasing in acceleration.
Decreasing acceleration.
Decreasing in speed.
Decreasing in speed. Alisa?
Decreasing in speed.
Decreasing in speed. Asna?
The rate at which an object slows down.
Okay, remember you have what is acceleration? A equals to V minus U over T. Right, acceleration or deceleration is actually a rate. What is acceleration? Rate of change in velocity.
Velocity.
Right, so what is deceleration? Rate of change in velocity. Right, rate of decrease in acceleration. So it's what? It got to be rate of decrease in velocity. What is acceleration? Rate of change in velocity or rate of increase in velocity. Got it?
Okay.
Now, so this is a speed time graph. What are two things you can get from speed time graph? Gradient equals to?
Acceleration.
Acceleration.
So acceleration. And area under the graph equals to?
Distance.
T, right? Okay. So now the distance traveled between t equals to 3, t equals to 6. So what's the answer?
24 meters.
24 meters. T equals to 3 and t equals to 6. So t equals to 3,
11.
11. And then t equals to 6 is how much?
5.
5.
So therefore half
Half times 5 plus 11
5 times 11
times
times
3.
3. Right. So 11 plus 5, 16. 16 divided by 2. 16 divided by 2 is 8. 8 times 3 is 24.
4.
Right. Okay. Now everyone got it? Yes?
Yes.
The deceleration between t equals to 3 and t equals to 6. Okay. Great.
So, deceleration we write in positive, right?
Your calculation has to be negative. And then
But
when
the
you
answer is positive.
Okay.
when you count, your answer should be negative. Okay, done. Master, what's the deceleration between t equals to 3, t equals to 6?
Sekejap, I belum buat lagi sebab baru balik toilet.
Okay. Balkis, what's the deceleration? I mean, A
Huh?
Negative.
A equals to V minus U over T. V equals to 5. U is 11. 5 minus 11 over 3 equals to negative 2
negative
Oh,
meter.
meter per second square.
Right, deceleration got to be 2 meter second. Right. Now, what happened to the size of the deceleration after t equals to 6?
It
So,
decreases.
6.
decreases.
How do you know it decreases?
It's less, the gradient is less steep.
Yes, the gradient is less steep. Right, it decreases. Right. What happened to the resultant force on the skater after t equals to 6?
Backwards?
The resultant one decreases.
Yes, because you have F
Oh, so
equals to MA, right? When deceleration decreases, therefore F also will be decreases, right? So
so
what
is
happens
that
to the resultant force? Resultant force
oh, it's just okay, decreases.
decreases, understand? Right, it's not backward or forward, just the resultant force decreases. If they ask you, there's one question down there that they ask you what actually what actually causes the decrease in the resultant force, so that may be increase in friction
Increase in friction,
and resistance.
air resistance.
Now, the speed of a cyclist reduces uniformly from 2.5 to 1 meter per second in 12 seconds. Calculate the deceleration of the cyclist
Yeah.
and the distance traveled. Okay, go.
Oh, okay.
Negative 0.125.
Plus U, A equals to
V minus U over
T
T.
minus U over T
equals to
1 minus 2.5 over 12.
So that will give you what?
Negative 0.125.
0.125.
So you
Uh,
0.1.
acceleration is negative 0.125.
Right. Okay.
Deceleration is 0.125.
Distance traveled by the cyclist in this time?
What? Distance.
Traveled by the cyclist in this time.
Uh,
I know if you do your SPM, your teacher has S equals to UT plus half AT squared, right?
In meter.
Yeah, but then in O level, you don't have that formula. So how do you find the distance traveled by the cyclist in this time?
half times 2.5 plus 1 times 12.
Okay, how do
The
Half
half times 2.5 plus 1.
what formula you're using?
The trapezium.
trapezium.
Because you have, okay, those of you yang tak tahu what Amin is talking about. Okay, here, okay, kalau you buat level, you don't have S equals to UT plus half AT squared. You do your SPM, you have that formula. O level, so what you do is simply speed of a cyclist reduced from 2.5 uniformly to 1. So this is 1. Okay, time taken is 12. So this is a trapezium, half times
Half times 2.5
2.5 plus 1
plus 1
times 12.
get it?
times 4.
Okay.
Yep.
Kalau we know what we are talking about. If you don't know, just stop me. I'll explain to you again.
21 meters.
Right. Okay. So this has to be 21 me. Right.
21 meters.
Yes.
Cik, yang formula tadi tak boleh guna lah.
S mana? S equals
Yang
No idea, never heard of that.
but the thing is in O level, if kalau you pakai tak apa juga, but generally the student O level don't do this. They're not exposed to this formula yet. You can use this. Kalau you pakai ni, so S equals to UT, U is berapa? 1, right? Times is 12 plus half A acceleration is 0.125 negative times T squared, 12 squared. So what do you get? You get 12. And then you have what? 12, 144. Get 9. So you have plus 9. So you're going to get 21 meters still. Okay. But you don't use this. Kalau O level, you tak pakai S equals to UT plus half AT squared. But if you write using that formula, you still get marks. Okay. Get it?
Yes.
Now, it shows the axis used to plot distance time graph. So on figure 1.1, draw a graph for an object that is moving with constant speed, label the graph A, and moving with decreasing speed, labeling the graph B. So this is a distance time graph. How does moving with constant speed looks like? Marisa, how does it look like? Constant speed. This is a distance time graph.
Line.
Right. So this is graph A, moving with decreasing speed. Marisa, how does it look like?
It's going down.
You've been going down like this.
Yeah.
Okay, now take a deep breath, Melissa. Ask yourself, this is a distance time graph. What can you get from distance time graph? Gradient equals to speed. Gradient. So if decreasing, meaning decreasing gradient, gradient, okay? So decreasing gradient means that your graph should be like that.
Instead, the line is less.
Okay, the graph should be less steep. Okay, the graph should be less steep because gradient equals to speed. So kalau dikata decreasing speed, meaning that this is decreasing gradient, it become less steep. Kalau increasing speed, like this. Speed, like that. Constant speed, like this. Okay. Therefore, basic things like this you have to know. It is imperative on you to know this. The basis of how you're going to proceed later. Okay, now it shows the axis used to plot the speed time graph. Draw the graph for an object. This is a speed time graph now. What are two things you get from speed time graph? Gradient equals to
Acceleration.
area under the graph equals to.
Distance.
So now moving with constant acceleration. Balkis, how does it look like?
Constant acceleration. Increase. Straight line.
Right. Increasing acceleration. A, B, C. How does it look like?
It looks like A. 8.
Right. So this is D. Understand?
Okay.
Okay, a plane is at rest at an airport runway. The brake of the plane are released and the engine of the plane provide a constant accelerating force. Using the following data, calculate the takeoff speed of the plane. Ignore any resistive force. So constant forward force is 5,000, 56,000. So you have, so constant forward force is 56,000 Newton. Mass is 16,000 kg. Time to travel 1 minute to 16 seconds. So now, take off speed. Okay, calculate now. Okay, done? Asna, you have some idea how to do it?
My brain is processing the question right now.
Your brain is processing the question. Okay. Alisa?
Teacher,
Yeah.
can we use the acceleration formula?
Okay, dia bagi apa Nina?
Constant.
They give you this. What's missing?
The
Now what's missing, right? How do it?
distance dia?
Distance.
Wait, teacher. Is it F equals to MA then times the time?
Dulu Min, buat dulu.
Okay.
Right.
Okay. Oh no.
Do it. Okay, the rest of you try. Lagi you tak try, lagi tu you tak boleh buat. Okay, try. Get it wrong first before you get it right. What have you learned so far? Okay. You learn A equals to V minus U over T. What else? F equals to M. That's all the things you learn. Like I say, when I say I go slow, I really go slow. Okay, Melissa, you have some idea how?
Not yet.
Not yet. Alkis?
I'm trying.
Oh, okay.
Kira jap.
Teacher,
Yeah.
I use F equals to ma. I got the acceleration and then I times with the speed and then I get the speed. I times with the time. I got the speed.
Acceleration. Yang you dapat acceleration ni, nah, careful.
Ya, lepas tu saya masukkan dalam
There's
velocity.
betul-betul. A plane is at rest now. Yeah, you're right. Your answer will be correct, but your processing tu kena betulkan sikit. Nah,
Okay.
when you process it, ada sikit je lagi tambah.
Maksud teacher yang
Teacher,
proses
Yes.
teacher. To find the teacher,
Yeah.
find the speed, we have to use the formula A equals to VU minus over T, right?
Yes.
So then move the T to the left, it will be acceleration times time equals to V minus U, where the U equals to 0 because it was in,
Yes.
the speed was 0 at rest.
Yeah, I got 56 teacher.
Okay. So like I said, Nina, your answer will be right, but your processing tadi you missed something because it says
Oh,
rest. So you know that U equals to 0. The rest of you see, the plane is at rest. So initial velocity is 0. They want you to find what is your V. They give you your F. They give you M. So from here, you go for F equals to MA. Right. So MA. So 50,000 equals to 16,000 times A. So A equals to 56 over 16. That will give you berapa? But
3.5.
that will give you
3.5.
3.5 meter per second. Now they want V. So your formula should be
3.5 meter per second square, teacher.
T minus U over T. So 3.5 equals to V is the one you're looking for. U is 0 over time taken is 16. So therefore,
12, teacher. Wait, sorry, 12, 66.
15 seconds.
Yeah, sorry.
Therefore, V equals to 1.5 times 16 berapa?
56 meter per second.
56, yes.
56.
Meter per second.
56 meter per second.
Now, you get that, Melissa?
Ah.
Yes.
You understand? Right. So it's not that you don't know how to do it. It's because you're not used to doing this kind of question. So the only cure to it is do a lot more. When you do a lot more, you'll be very sharp at looking at what's given, what's missing, and look at 4 marks. Meaning that I have to find my acceleration first. So once you get your acceleration up to here, you get 2 marks. And then you put it here, you get another 2 marks. That's 4 marks there. Okay? Now, define acceleration, blah, blah, blah. Okay, 2 minutes here. Quick. Okay, done. Now define acceleration, Melissa.
Rate of increase in velocity.
Right, good. You get it now, right? Rate of increase in velocity because A equals to V minus U over T.
T.
Right. Rate of increase in velocity. What is deceleration?
Rate of decrease
Yes,
in
rate of
velocity.
velocity. You have to put rate there over time. Now it shows the distance time graph for the journey of a cyclist. Describe the motion of the cyclist in the time between t equals to 0 and 15. So between 0 and 15. Melissa. How do you describe the motion, Melissa? This is a distance time graph. What? Ask yourself. What can you get from a distance time graph?
Speed.
You get speed. Okay, now, so between 0 to 15, so gradient equals to speed. Look at the gradient between 0 to 15, Melissa. Increasing, is it getting steeper or is it getting less steep or it's constant?
It's increasing.
It's increasing. So your answer should be what? Describe the motion of the cyclist in time between 0 and 15. So increasing what?
Speed.
Increasing speed. Okay, now 15 and 30. 15 and 30.
Constant speed.
Constant speed. Now 30 and 40.
Decreasing.
Decreasing speed. Right, calculate for the 40-second journey, average speed. What's the formula for average speed?
Total distance over total time.
Time taken.
Total distance over total
Total time.
time. So what is the total distance travel here?
300 meter.
Over 40.
40. 30 over 40, that will give you berapa? 7.5
7.5 meter per second.
per second. Right. What is the maximum speed? Remember, this is a what? This is a distance time graph. Gradient equals to
Speed.
speed. So which part of the graph are you looking for? You're looking for the steepest graph or the least steep?
From the 0 to
The
15 graph.
steepest graph.
Okay, 0 to 15. Okay, now you know that 0 to 15 is the steepest part of the graph. Now next question,
Oh, okay.
how do you find the gradient of the graph?
Y2 minus Y1 over S2 minus S1.
No, because this one is not a straight line. Nampak? Dia macam tu.
Oh,
Nampak tak? Kalau dia straight line, yes, you use y1 minus y2 over x.
Oh.
It's not, right? This is like this. Right. So what should you do? Go back to your map. Draw a what? Draw at any point between 5 to 15. Okay, draw tangent. Okay, use your ruler. Draw a tangent. Okay, tangent to the curve. Get it? So draw tangent to the curve. Okay, draw tangent to the curve. Get it? Understand? Okay. So take your ruler. Place your ruler here. Oh, sorry. What's the answer? 4 cross at this point, right? Okay. Now, what is this? 100 and berapa? 100 and quick. So it will be 120 over 20, 122, right? 522 and 17. So how much is that? 120 divided by 17. You get 7. Okay. Is it? That and you want to find it again, do the same thing. Okay. Draw 10, tangent to it, and then yeah, understand?
Yes.
Yes.
Now here. Now a small rubber ball falls vertically, hits the ground, rebound vertically upwards. So you have a small rubber ball. Hit the ground and then it rebounds back vertically. Okay. Now this is a speed time graph for the ball. Balkis, read the answer.
From A to B, the small rubber ball falls at constant acceleration.
Okay, this is 3 marks, 2 marks up there.
Oh.
So,
Yeah.
if I say from A to B, the ball moves at constant acceleration from 0 meter per second squared is
Yes. You have to mention.
to 9.5 meter per second squared for 0.9 seconds.
Yes. Right. So you talk about from A to B, constant.
There's a constant acceleration
From 0 to 0.
from 0 meter second to 10 meter second.
Progress to 9.5
9.5 meter per second.
meter per second. Right. Okay. Now part D. Now part D.
Yes.
DE should be constant.
Deceleration.
Deceleration. Okay. What else?
From 8 meter per second squared to 0 meter per second.
Yeah, but what happened
Squared.
at E?
It comes at a
Oh,
rest.
they
Yes.
comes at rest.
Rest.
It comes at
What's the time here?
1.6.
1.8.
0.
I come to
Oh,
1.8.
1.8.
1.6.
Here, 2 is 1, 1.5, 1.6, 1.7, 1.8. Right. Constant
Yeah.
deceleration
At 1.8 seconds.
Comes at a rest.
and come to rest or come to rest at 1.8 second or it stops at 1.8. Okay, now what is happening to the ball along the path of the graph from B to C to D? Okay, answer. Alisa, you want to try? Answer?
What? From C to D,
The ball, yes.
I wrote the ball hits the ground and sharply decelerates until it is at a rest for a short while. The ball then rebounds and accelerates exponentially.
Okay, what happened to the ball along the path of the graph from B to C to D? B to C, between B to C is just about to hit the ground. Okay, so from B to C, it hits the
ground.
Okay, a little bit more. Once it hit the ground, before it falls from a height. So what kind of energy the ball have?
Gravitational potential
As it
energy.
falls down, the gravitational potential energy changes into
Elastic
Kinetic.
potential.
Kinetic energy.
Kinetic energy as it hit the ground. Baca ni is a small rubber ball. What do you know about rubber ball?
Bounce.
It's
It's elastic.
Elastic.
As
Oh,
it
yeah.
ground, what happened to the kinetic energy?
It becomes
it
elastic
changes
potential energy.
into elastic potential
Elastic
energy.
potential energy.
No energy, right? It hits the ground, then the kinetic energy, the kinetic energy is converted into
Elastic potential energy.
elastic potential energy, which that apa, between C to D, what happened?
It bounces back.
It rebounds.
Right, that's it. It rebounds. Okay. So this is 2 marks. So you have to remember B to C, it hits the ground. Now, because the question asks you what is happening to the ball. Okay. It hits the ground. So now the next question you should ask yourself, as it hit the ground, what happened? So just now it's moving. So it's kinetic energy. Now, and then this is a plastic ball. So plastic ball is elastic. So as it hit the ground, the kinetic energy is changed into elastic potential energy. And then at C to D, it rebounds back. It rebounds upward. Okay. Now, while the ball is in contact with the ground, what is the overall change in speed? What is the overall change in speed? I mean, what's the overall change in speed?
9.5 meters per second.
No, overall change in speed as the ball is in contact with the ground. So initially, it's what? Just before it hit the ground, what it is? 9 point,
1.5. 1.5.
and then 0. And then it goes up to 8.
8.
So what is the overall change in speed?
1.5.
1.5, because you have 9.5.
Oh, that okay, both things.
9.5 minus,
1 point, minus 8.
so that will give you 1
1.5.
per second. But what is the overall change in velocity? Remember, it falls down and then it go up. And remember, what's the difference between velocity and speed?
Velocity is speed in the direction.
So what's your answer, Balkis?
Negative. Oh,
Negative 4.
Huh?
Negative 4.
Negative 4. Nina?
Yeah.
negative 1.5.
Negative 1.5. Remember, just now, tadi yang you buat tadi, bila dia pusing balik, when opposite direction, you have to put negative. So initially, it's 9.5, right?
Ah, yeah.
0.5. Now it go in the opposite direction, which is negative 8.
1.5.
Now, what is the change in velocity? It should be 9.5 minus 8. Get it?
Okay.
Okay. Nampak tak? 9.5 minus 8. Why minus 8? Because it's going in the opposite direction.
Opposite direction.
Right. So therefore, it should be what? 17? 5 meter per second.
What?
Get it right?
17.5. No.
No. But if I ask you what is velocity, what is speed, you know. Right. And you know that the opposite direction is actually negative. So put that here in this. So be careful because they want overall change. As it goes down, 0.5. As it goes up, is negative 8. Why negative 8 meter per second? Because it's moving in the opposite direction. Why again? Because velocity is a vector quantity. But if they just ask for change in speed, okay? Now use your answer to explain the difference between speed and velocity. How do you explain the difference between speed and velocity? If I ask just without referring to seeing, what is the difference between speed and velocity, everyone?
Speed.
Speed is the lead.
Velocity has a
Speed is a scalar quantity, while velocity is a vector quantity.
With this knowledge, answer this. Answer this based on this. So explain the difference between speed and velocity. Everyone take it. Proceed. Proceed. Without, what happened to ball?
Huh?
The
As
ball.
ball fall and touches the ground, direction changes. As direction changes, velocity changes.
But speed stays the same.
As it changes,
With reference to the ball. As the balls and hit the ground, what happened? Direction changes and velocity changes. From what? From 9.5 meter per second to negative 8 meter per second. Understand? Get it? See what I'm trying to say here? If I ask you speed, laju je, speed is a scalar quantity, velocity is a vector quantity. It says, but in context, you have to be able to explain it in context. Okay. Now, this graph traveled by the ball between D and E. So distance travel. This is a speed time graph. How do you get distance travel?
Area under the graph.
area and the
What shape is it?
Triangle.
triangle.
Therefore, half times
1.8. 0.8 times 8.
0.8 times T. Right. So that will give you what? 3.2 meter. Okay. Okay. Now, use the graph to calculate the deceleration of the ball between D and E. So what is the deceleration of the ball? A equals to minus over. Lisa, you want to try this? What is your V?
0,
0 minus
8,
over.
0.8,
Right. So that would be
negative 10.
10 meter per second squared. Right. So, but when you put your calculation, you have to put negative. But in your answer, because this is deceleration, so okay. Now, okay. Now, define acceleration again.
The rate of increasing velocity.
Rate of increase in velocity. Shows the speed time axis for the graph of the motion of a car. The car starts from rest. From 0 to 15, the car has a constant acceleration to a speed of 28. So how does it look like?
Straight line up ke atas.
So 15, you have 28. So where is 28? This is 25, 28 is here. 28, so from 0 until 20. What happened?
Constant.
Speed.
Horizontal line.
Okay.
Horizontal line.
For how long? Until 30.
15 to
to 32.
32 seconds.
Right, until 32 second, until 32. Wait, 30, 30, 31. After that,
Teacher, the car stops at 46 seconds, right?
at 20 times 30 seconds, the car has a constant deceleration until it crashes. So it has a constant deceleration of 2 meters per second. Okay, here it says use your draw new. The deceleration means when does it stop? Melissa, when does it stop? I give you the clue here. The car has a constant deceleration. A equals to?
A equals to V minus U over T.
So you have 2 equals to?
2 equals to teacher negative 2.
Yeah, negative 2 is okay. Equals to? V, you don't know what V is, right? V is 0 minus 2 over T. So 0 minus 28 over time. So what is your time?
Time. Oh, mine.
14.
Okay.
14 seconds.
So
Yes.
you start off at 32. 32 plus 14,
36, 46
46. So 46 is
stops.
1, 2, 1, 2, 3, 4, 5, 6 is here. Right. So it stops at 46.
Mm, mm, mm. A bit teacher. Oh.
Got it?
Yes.
Okay. Everyone got it?
Mm, mm. Yes.
Yes, you should be able to get it before I draw. Right. Okay, everyone got this? Yes?
14 seconds.
Did you get it?
Yes.
Yes. Okay. Now, from time 15 to 32, the path of the car is part of a circle. So 15 to 32 is part of a circle. For this motion state, the direction of the resultant force. Okay, I mentioned this just now. If you are in a circle, what changes as you move in a circle?
The direction.
Your speed is constant, right? Why speed is constant? Because the distance covered is constant. Okay, it's just the circumference of the circle, so it's constant. But direction changes. So as direction changes, there'll be a change in
Velocity.
Velocity.
right? Velocity. So as there is a change in velocity, what is change in velocity? It will be acceleration.
Acceleration.
Right. And this, when there is an acceleration, there'll be a force because you have ma. Right. When there is an acceleration, there will be a force. And this force is what you call centripetal force. Okay. And the direction of the force is actually inwards towards the center of the circle. And the effect of this force is actually it keeps the object in circular motion. Okay. Say you pernah naik LRT tak? Kan, all of you pernah naik. Naik LRT sampai dekat, I think lepas Damai or something yang dia ada cornering tu. Dia cornering, right? So when there's a cornering or when there's a roundabout or something, right? As it moves, there's a force actually inwards. If you're taking the LRT, there's a force inwards that keep the train moving in circular motion. So that is what you call centripetal force. When it's maneuvering the cornering, so what happened is actually the speed is constant, but there is an acceleration, okay? And this force is what you call centripetal force. It prevents the car or the train from tumbling over, okay? So you have centripetal force. So centripetal force is like, okay, katalah you tahu tak those the Scottish play this game where ada macam batu or something heavy and then they round and round and round and round, dia pusing tu kan. So when
The short part teacher.
the something like that. Tapi short part kita pegang, ini tak. Ini dia
Oh,
orang
sorry.
dia
Yeah, yeah. It's the
something like a
yeah.
short part juga. Right. So what happened when you go round, or you see your fan is going round and round and round, or you see Ferris wheel, right? It go round and round and round. So what keep it going round and round is actually centripetal force. Okay. But if you move and the speed is getting faster and faster, what happened would be it will go off tangent. Okay. If the forward force is greater than the centripetal force, it will go off tangent to the circle. Remember that they do.
Oh wow.
Okay.
So teacher,
Yes.
when they go round and round and release the thing, it goes off in a straight line.
It goes off in a straight line. Not yeah, it goes off in a straight line tangent to the circle. Okay.
Tangent to the circle. Okay.
You tak percaya, you ambil eraser ke apa or plasticine ke, you lekat dekat your fan, right? And then you turn, you know, if you can adjust the speed of your fan as it go faster and faster and faster, you notice that the blue tag or the plasticine will just go off tangent, right? Okay. Now, from so the motion direction, okay. So here it says, this is part of a circle. So when you talk about part of a circle, the direction of the resultant force is inwards towards the center of the circle. What do you call this force? Centripetal force. Remember petal of a flower, so centripetal, in the middle of the petal, centripetal force. Later on, you go to your foundation, you go to your A level, you learn about centrifugal force. Okay, that's another force there. What happened to the velocity of the car? The
Changes.
that speed is constant, but the velocity as it moves in circle, velocity change? Will the velocity change or remain constant?
Change.
Changes.
Change.
So what happened to the velocity? Velocity change.
So teacher just changes.
Yeah, velocity changes, right? Because what is change in velocity? Change in velocity is acceleration, right? And when there's an acceleration, there will be force. What do you call this force? Centripetal force. Why there is a change in velocity? Because it's moving in circle. As it moving in circle, the direction change. As direction change, velocity change. Your velocity is speed in the direction. Right. Okay. Okay, now here. 5 minutes or less, if you can. Okay, start.
Wait, teacher, the force pulls it inwards.
Yes. Okay, done. Done. Okay, Asna, done. Marisa?
Almost.
Almost. Okay, a bus travel. Now, bus travel from one bus stop to the next. The journey has 3 distinct parts stated in order. The uniform acceleration from rest for 8 seconds, uniform speed for 12 seconds, non-uniform deceleration for 5 seconds. Okay, complete the graph for the first 2 parts. Uniform acceleration from rest for 8 seconds, uniform speed for 12 seconds. Okay, for 8 seconds. So 8 seconds, 5, 6, 7, 8. Right. So for 8 seconds and then uniform speed for 12 seconds. So here, so you just right. So after that, uniform speed for 12 seconds and then a non-uniform deceleration. Right. Okay. Everyone got it right? Yes, no?
Yes.
Yes. Now calculate the acceleration of the bus 4 seconds after leaving the first bus stop. Balkis, what's your answer? Balkis, what's your answer? Nina,
Yes.
what's your answer?
Wait.
What's your V? V is 10, 11, 12, right? 12 minus 0 over 8. How much is that? 12 over 8? 1.6, right? Betul tak?
1.5, teacher.
1.5.
Wait,
Right.
teacher, isn't it supposed to be 4 seconds after leaving the bus?
This is the 4 seconds after leaving the first bus stop. 4 seconds after leaving the bus stop is the bus travel from one bus stop to the next. That's three distinct part. Calculate the acceleration about 4 seconds after leaving the bus stop. So still sama juga Min. Sebab this is constant acceleration. Nampak?
Okay.
This is constant acceleration. So it doesn't matter which point, at which point do you measure, you still should get the same pair.
Same answer.
Okay, same answer wherever your triangle is, you should get the same answer. Right, which is
Okay.
1 point,
It's still 1.5 meter per second, yes.
yes, 1.5 meters.
Per second squared.
Now use a graph to estimate the distance the bus traveled between 20 seconds and 25 seconds. So this look like a what?
A triangle.
Also half
Half
Times 5 times
height
12.
5 times 12.
times 5, right? So 6 times 5, that will give you
30.
Meter.
On leaving the second bus stop, the uniform acceleration of the bus is 1.2 meters second squared. Okay. Now, the mass of the bus and the passenger is 400 kg. Accelerating force acting on the bus. What formula you use?
F equals to MA.
F equals to MA.
F equals to ma. Right. So mass equals to 400. Accelerating force is 1.2. That will give you 400 and
4,000.
4,800
800 Newton.
Newton.
The acceleration of the bus from the second bus stop is less than that from the first bus stop. Suggest two reasons why.
The bus is running out of fuel.
The bus is running out of fuel. Okay, what else?
The road is rocky.
The road is rocky. Friction increases, right?
Yes.
So you talk about increase in friction. Right, increase friction, what else? Less fuel, right?
Yeah.
That, or otherwise you
More
talk
passengers.
F, yes, F equals to MA. So if you pause, so therefore you have M equals to F over A, right? So the more the mass, the lower the acceleration. So you talk about more
Passengers.
passengers board
On the bus.
the bus, right? Okay, more passengers on the bus. Okay, got it? Now, driving instructor give a student a sudden order to stop the car in the shortest possible time. It shows the speed time graph of a motion of the car from the moment the order is given. So now, what do you notice here? For the first 9 seconds, it travels at a constant speed of
Teacher, there's only 5 seconds.
5 seconds. 5 seconds.
0.9.
0.9, teacher.
Okay, at 0.9, what happened?
It's at a constant
At a
speed.
constant speed of 18 meters per second. And then between 0.9 until 4, it decelerate constantly. And then it stop at 4. Right. The order to stop is given at t equals to 0. So the order to stop, the instructor says stop here. But then you notice it's moving at a constant speed for 0.9 seconds. State the speed of the car at t equals to 0.
18, sorry.
Right, suggest why the car continue to travel at this speed for 0.9 seconds.
Sound travels at Sound travels at 300 meter per second.
Apa ni teacher tulis?
Inertia.
Inertia, sorry.
Okay, because when you go for Newton's second, when you go for Newton first law, what is Newton first law? When there's no resultant force, okay, what happened? The object is either stationary
Or constantly move.
speed. Right, and then if it's moving, it will keep moving. If it's stationary, it will keep stationary. Get it? If it's stationary, it will prefer to be stationary. If it's moving at a constant speed, it prefer to be moving. So this is what you call inertia, right? You get that? Inertia. So remember we discussed it before this. It's like if you are on the LRT stop, you stop as well. Then the LRT move forward. As the LRT move forward, if you don't hold on to anything, back, right? Or you're driving, your mom is driving a car, and then all of a sudden she brake. Immediately she brake. So what happened to you? You move forward.
Move forward.
As the car moves, you move with the car. Now the car suddenly brakes, you refuse to stop. So what happened? You move forward. Okay? You get that? Inertia. Like how do you get a ketchup or sauce tomato or ketchup out of a bottle? How do you get it out?
Ketuk.
When you shake it, remember, initially the ketchup is stationary in the bottle. Now you move it. The ketchup refused to move. What's the effect of it? It go forward. If you have an umbrella, the umbrella is wet. How do you dry your umbrella?
You shake it.
You shake it, you twirl it, right? You twirl it. You know what twirling
Twirl,
is?
yes, twirl.
When you twirl, what happened? Remember, the water is on the umbrella. The water is stationary. The umbrella is stationary. Now the umbrella moved. The water refused to move. What's the effect of the water? The water will be splashed.
Splash away.
You have a cat. You see your cat go out in the rain. How does your cat dry itself?
It doesn't
Shakes
twirl.
itself.
Take itself, right? Because the water is on the fur. So the water is stationary. The fur is stationary. Now it moves its body. The water refused to move. What happened? You get that? So that is inertia. So I remember I said what? We suffer from inertia too, right? At times you feel like, okay, I want to finish my work. I want to finish my past paper. I want to do all the work Teacher Muslah give me. Okay, that was 9 o'clock in the morning. And then 12 o'clock come. Tak apalah, tidur sekejap lah. Kejap lagi lah pukul 2. Right? And then after that, the time. Tak apalah, tomorrow lah I buat. And all you know, 1 week goes by and your homework is still not done. Right? Because you suffer from inertia. And remember, what did I say? This is 20 Newton this way. This is 20 Newton this way. You just need 21 Newton. This is 20 Newton. The urge for you not to do your work or tak apalah, nantilah lambat lagi nak buka sekolah. It's 20 Newton. You only need one more extra Newton here for you to overcome the inertia. Okay? Only, even if 20.5 is enough. Right? So because everyone suffer from inertia. Don't be one of those people. Okay? So if it stop, it keep on. It prefer to stop. If it's not moving, it prefer to not moving. If it's moving, it refuse to stop. That is inertia. So why the car continue to travel at this speed for 0.9 seconds? Because of
Inertia.
inertia. Right. Okay. Inertia. And then another thing also is because of, this is what you call reaction time. When you see something on nervous system, you have what you call reaction time. So you put inertia, you get 1 mark, or otherwise another one is reaction time. Okay, that 0.9 second is the reaction time. Okay, mean that it takes time for your eye to register, for your ear to register, and for it
to move the brakes. Press the brake.
Yeah, press the brake and everything. That is what you call reaction time. You answer your reaction time, you get it right. You answer inertia, also you get it right. Okay, deceleration of the car between t equals to 0.9% and t equals to 4. So this will be gradient of the graph, right?
We didn't have to
So just draw anywhere, or you can draw a big triangle. It's okay. So what is that? That is
0.9.
that is what? 18. So 0 minus 18 over 3, right? So that will give you -6 meters second squared. So meters second squared. Total distance traveled by the car from t equals to 0. What shape is this? This is a trapezium, so half times 0.9 plus 4 times 18, right? That will give 9 times 49 berapa? That will be 44 points. Okay. Now describe and explain the danger to a driver of not wearing a safety belt during a sudden stop. So when you talk about inertia, the tendency is what? This is a dashboard, this is you. What happened? The car stop, you stop. What happened to you?
Your face hits
Move
the
forward.
dashboard.
Face moves
You
forward.
move forward and hit the dashboard.
So why do you need to wear safety belt?
To prevent
To prevent from
inertia.
No, inertia
Oh,
was
sorry. No.
to prevent from
Moving
hitting
forward.
Hitting your head on the dashboard.
satu lagi. Remember here you have F equals to M
MA.
equals to M V minus U over T. Remember, so those of you, I will cover momentum with you, but those who have done momentum, remember what is this?
Impulsive force.
Force. So when you wear your safety belt, what happens is you are increasing the time of collision between you and the dashboard or the wheel.
Oh.
The time you reduce the force. Get it?
So,
So describe
oh.
to a driver of not wearing safety belt. Right, so there'll be more injury because what does safety belt do? Safety belt will increase the time of collision. So when increase the time of collision, therefore we
Reducing the impulse.
injury. Okay. Remember, I give an example like you cycle outside on a jalan tar and you cycle in front of your porch with tiles, yang licin. So when you brake your bicycle, which one brake faster? Which one stop dulu? When you are out dekat jalan tak, betul tak? When you fall,
Oh, that hurts.
which one give you more injury?
What? Yes, teacher.
Which one
What?
give you more injury? You jatuh dekat jalan tar ke you jatuh dekat porch yang ada tiles?
Jalan. Wait.
Apa?
Tiles.
More.
Tiles.
Why tiles? Tiles is
Wait.
licin. Time taken to stop the bicycle is more. Injury is less. You jatuh kat jalan tar,
Oh,
jalan
wait, bicycle. Oh, bicycle. Yeah.
more. When friction is more, time taken is less.
Time.
Force is greater. The injury is greater.
Yes.
Remember, those of you yang haven't done your momentum will cover this your next class. Not your next class. Your next class is resultant force. The next class after. Now, the danger of a driver not wearing a safety belt, there'll be more injury.
More injury.
Right? There'll be more injury. And then what else? Because, describe and explain, there'll be more injury. Reason, because the
Time
collision
taken.
time is shortened, therefore there'll be more impulsive force. You decrease collision time, more impulsive force, more injury. Now the car starting from rest complete one lap of the track in 10 seconds. Its motion is shown graphically in figure 1.2. Describe the motion between 3 and 10 seconds after the car has started. 3 and 10
Constant acceleration.
Constant acceleration. Okay, sorry.
No.
Constant speed.
No. Constant.
Use figure 1.2 to calculate the circumference of the track. So circumference of the track area under the.
Distance.
So which is what? half time?
Half times 25. Wait, 10 plus
25
times 20.
plus
Times 25 divided by 2. That will be 162.5. Right. Calculate the increase in speed per second during the time 0 to 3.
Wait, teacher.
Yes.
Isn't it supposed to be 7 plus 10?
Wait. Half times berapa ni? Sorry. 10, yeah, 7. Sorry. 7 plus 10. Okay. Now calculate the increase in speed per second during the time 0 to 3.
0 to 3.
Oh, okay.
25.
The speed, teacher, they're asking. Yeah, they're asking for acceleration.
So what is that?
Equals
25 over 3, 8.33.
Right. Okay. Now, I don't know how many pages I give you. I think I give a lot, right? Yeah.
31,
Yes.
37.
37. Okay.
37
Those of
pages.
you yang still, because this is, you are supposed to be good with this chapter. Simply said, you're supposed to be good with this chapter. You only have two formula, A equals to V minus U over T, F equals to MA. Don't worry about the momentum and all those yet. The one I give you here don't have any momentum. And that I just explained because some of you have done momentum.